Hi everyone and welcome to the Learning Curve. In this video I will be continuing my series reviewing typical final examination questions for students studying mathematics for business, economics or social sciences in general at universities in level 1. And here we are asked to find the stationary points of the function f of x equal x cubed plus 3x squared minus 2 and classify them as either local maxima, local minima, or neither. The first thing to do when you are asked to find the stationary points of a function, which is what we have to do first before we can classify the points as either local maxima or local minima, is that we want to take the first derivative of the function. So the function we have here is f of x equal x cubed. So f of x equal x cubed plus 3x squared minus 2. And what we want to do firstly is to find the first derivative. The first derivative f prime x is going to be equal to, now when we differentiate x cubed, we're going to get 3x squared because the 3 comes down to the front of x and we subtract 1 from that power of 3, giving us 3x squared. Similarly, when we differentiate 3x squared, we're going to multiply the 2 by the term at the front. So 2 comes down to the front here and we multiply by 3, which gives us 6, and we subtract 1 from that power of 2, giving us 1. So we leave that as an invisible 1. And when we differentiate the constant of negative 2, we will get 0. Okay? So when we differentiate any constant, we get 0. So we are essentially therefore left with f prime x equal 3x squared plus 6x. That's what we're left with. And in order to find the stationary points, what we're going to do is that we're going to set f prime x equal to 0. So the first thing to do when you're finding stationary points from a polynomial function like this is to find the first derivative. That is to differentiate the function once, which we did here. And then the stationary points occur where the first derivative, f prime x, is equal to 0. So, since we know that f prime x was found to be 3x squared plus 6x, we're going to set 3x squared plus 6x equal to 0, and then we're going to factor it. We're going to factorize 3x squared plus 6x. This is one of those factoring situations where you need to identify the highest common factor because there is no constant in this quadratic function. Because there's no constant, what we need to do is just identify the highest common factor between both terms. That is the highest term that can go into both expressions. The highest term that can go into 3x squared and also 6x. So this highest term that can go into both 3x squared and 6x is 3x. So we factor out 3x. 3x will, and then we'll divide 3x into 3x squared and also into 6x. So we factor out 3x because it is the highest term that can go into both 3x squared and 6x without a remainder. So 3x divided into 3x squared is going to give us x, because 3 cancels 3, and x divides into x squared, x to the first times. And then 3x will divide into 6x twice, because 2 multiplied by 3x will give us 6x equal 0. So these are the factors. So therefore, the factors are 3x, the factors of this quadratic equation. 3x squared plus 6 are 3x and x plus 2. So what we're going to do is to set each of the factors, 3x and x plus 2, individually equal to 0. So 3x is equal to 0. And then we're going to solve for x. If 3x is equal to 0, then x would be equal to 0 as well. Because if 3x is equal to 0 and we're solving for x, we will divide by 3 to get x on its own, and what you do to one side of the equation you have to do to the other side. So 3 cancels 3 here, and x would be equal to 0 upon 3. That is 0 divided by 3, which is 0. So x is equal to 0 when we set one of the expressions in the product, which is 3x equal to 0. And then we're going to also set the x plus 2 equal to 0. So and x plus 2 equal to 0. So what we're doing here is that we're finding the stationary points. That is the points of x, or the values of x, where the first derivative is equal to 0. So x plus 2 is equal to 0. So if x plus 2 is equal to 0, then to get x on its own by inverse operation, we're going to minus 2 from both sides of the equation. So this positive 2 will be negative on the right side of the equation, so that x would be equal to 0 minus 2, which is minus 2. So therefore, the values of x, which are the stationary points, are 0 and negative 2. These are the stationary points. And so 0 and negative 2 are the stationary points. So already, we have found the stationary points of the function. So these are the stationary points. And having found the stationary points, the next thing that we're going to do is that we're going to classify them as either a local maxima, which is when the function looks like this, or a local minima, which is when the function looks like this. All right, so let's go ahead and do that. So to classify the stationary points of 0 and negative 2 that we found, we're going to take the second derivative, right? So to classify the stationary points, we're going to find the second derivative. And then when we find the second derivative, we're going to substitute each of the stationary points into the second derivative to replace x. And then we're going to solve. So f prime x was earlier found to be, we found f prime x here to be here, 3x squared plus 6x. That's f prime x, 3x squared plus 6x. So we're going to find the second derivative, which is to differentiate the first derivative. So that's what we need to do to classify the stationary points that we find as either local max or local min. So taking the second derivative here of 3x squared is going to give us 2 will come down to the front of the expression here. We're differentiating one term at a time. So the 2 comes down to the front here and multiplies by 3 to give us 6x. And we will take 1 from the power of 2, leaving us with an invisible 1. So that will be 6x. When we differentiate 3x squared, we get 6x. And when we differentiate 6x, we will just get the term that is multiplied by x, which is 6, because the power of x here is an invisible 1, so that would just be 6. So the second derivative is 6x plus 6. And what we're going to do now is that we're going to evaluate the second derivative for each of these stationary points. So we're going to say, therefore, when x is equal to 0, what would the second derivative be? F double prime of 0 would be equal to 6 multiplied by, we're going to substitute the value of x here, which is 0, to replace the 0 here, to replace the x here. So this will be 6 multiplied by 0 plus 6. Any number multiplied by 0 gives us 0, so we get 0 plus 6, which is going to be equal to 6. So what we have found here is that therefore f double prime of 0, that is when we substitute 0 for x in the second derivative, f double prime of 0 here is greater than 0. When the second derivative is evaluated for the stationary points and we get a value greater than 0, therefore there is a relative minimum. Right? So that's how it works. When the second derivative, when you substitute the stationary point or a stationary point into the second derivative and you get a result that is greater than 0, it means that there is a local minimum. Is a local minimum at x equal 0. And the final thing we have to do is to say when x is equal to 0, so we're going to test the other stationary point to see whether a local max or local min exists there. When we evaluate the second derivative for the stationary point, again, if the result is greater than 0, it means that there's a local minimum. But if the result is less than 0, it means that there's a local maximum. So let's see. So when x is equal to 2, f double prime, that's negative 2. When x is equal to negative 2, which is the second stationary point that we found by factorizing the quadratic that we got from the first derivative. When f double prime, so we're going to evaluate f double prime of negative 2, which means that we're going to use negative 2 to replace this x right here in the second derivative. So we're going to have 6 multiplied by negative 2 plus 6, substituting it into the second derivative here, plus 6, which gives us 6 multiplied by negative 2 is negative 12, and negative 12 plus 6 is going to be equal to negative 6. Negative 12 plus 6 is the same as 6 minus 12, so that's negative 6. So because we get an answer here, that is, so I'm going to say, therefore, f double prime of negative 6, f double prime of negative 6 here, is less than 0. When the stationary point is substituted into the second derivative and it gives you a value less than 0, then it means that there is a local, so therefore there is a local maximum. Is a local maximum at x equal negative 6. So there's a local maximum at that point. And that is how we find stationary points from a polynomial and then subsequently classify them as either local maximum or local minimum points. And I hope you found this lesson to be very useful in finding stationary points of a function and also classifying them as local maxima and local minima or local minima. Much more to come as I continue my lesson series on reviewing typical past paper questions for students in universities studying mathematics for business, economics, or the social sciences. Remember to like, share, and subscribe. Thank you very much, and see you soon as we continue our indulgence in the world of mathematics and statistics.